Hello, my name is Stephanie Rust, and today I am going to be introducing the method of performing a constant head permeability test. Today we're going to need a few pieces of equipment to complete this. One thing that we will need is a reservoir connected with some hoses that will have an outlet into the sink, an inlet to a nearby water source, and several outlet availabilities for your permeability testing. We will also be needing some very clean, coarse-grain aggregates. We will need a thermometer, a stopwatch, a 250 milliliter graduated cylinder. We will need some wire mesh discs and some porous stones. There is a porous stone in here. And this is a permeameter, which we will also be using. You will need a funnel, a vernier caliper, a regular ruler in inches, and you will also need a coarse-grained soil. We're using sand in this case. The first thing that we are going to do is prepare our soil sample within the permeameter. In order to do this, we need to know how much soil to place in the permeameter, but first we are going to ensure that we have a porous stone in the bottom, which you can see that there is, and we're next going to place a wire mesh disc into the bottom. The wire mesh disc simply keeps any soil particles from escaping into the bottom of the permeameter. Before you place the soil in the permeameter, you need to weigh the soil in the source container. Make sure that your scale is tailored. Take the measurement and record. You will then place the soil in the permeameter as required. After you've placed the soil in the permeameter, you will weigh the source container again, record that weight, and the difference between the two is the weight of soil placed within the permeameter. In order to determine how much soil we are going to need, we are going to use the vernier caliper in order to measure the inner diameter of the permeameter. From this reading, we can see that it is approximately 2.5 inches in diameter. According to the ASTM regulations, the amount of soil needed from the inlet point to the top of your sample is 2 times the inner diameter of your permeameter. So we are going to need 5 inches from this center point up to the top of our sample. In order to place the specimen within the permeameter, I'm going to need another pair of hands, so my assistant Betty is going to aid me by holding the ruler while I place the sand with the funnel. You may have to stop and shake the permeameter a bit to make sure you have it level and you're measuring correctly. And you can see that we have the 5-inch mark from the center of the inlet to the top of the soil sample. The next thing that we're going to do is place a second wire mesh on top of the soil sample, again, to keep any soil from escaping during uplift. From there, we're going to place some of our stone aggregates on top, and this is simply to weigh down the sample. Water can flow freely through this, so as far as the sample is concerned, this is nothing but air. We are simply weighing down the soil so we won't have any uplift effects. The next thing that we are going to do is we are going to hook the sample to the water setup. The water source is connected to a faucet. The faucet runs into the reservoir, and the reservoir has an outlet which will enable constant flow, and the outlet as well is available to the permeameters. We're going to need 2 people to perform this, 1 person to monitor the flow of water into the reservoir, and Betty is going to begin and start the sink for us. You also need to unclamp your hose so that water can flow into your system. I'm going to want to slow down just a little bit with the water. And we're waiting for equilibrium to be matched. And you will see that the outlet is now going into our catcher. In order to determine that equilibrium has been reached, you will want to observe the water level in the manometer. When this is no longer moving or is at a steady state, you know that equilibrium has been reached. The next step is to measure the difference in total head. This is measured from the difference between the top of the water level in the permeameter and the water level in the manometer. A simple ruler can be used to determine this distance. Once you have determined and recorded the difference in total head, you are going to measure how long it takes to fill one graduated cylinder of 250 milliliters with the water. So you will need a stopwatch and your cylinder. When the person places this under, you're going to immediately press start. The water has now reached 250 milliliters. You will record that time and repeat this sequence 3 times. The average will then be taken to use in your calculations. The next step, every time you measure the water timing, is to measure the temperature of the water in the cylinder and to record this as well. There will be a temperature correction within the calculations to take this into account. Once you have successfully completed your measurements 4 times, you have accumulated enough data to perform your calculations. You may now disassemble your equipment and the test is complete.